In this video, we're going to teach you how to convert from decimal to hexadecimal and vice versa. So there's 4 sections. The first section is unsigned decimal to hexadecimal. The second is unsigned hexadecimal to decimal. The third is signed decimal to hexadecimal. And the fourth is signed hexadecimal to decimal. So first we need to know what the hexadecimal is. We all know what decimal is, which is a base 10 system, which means it uses 10 symbols. So going from 0 to 9. Using all 10 of those symbols. Hexadecimal is a base 16 system, which means it uses 16 symbols. So it uses from 0 to 9, and then starting from 10 it uses A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. Alright, for this example we're going to go from unsigned decimal to hexadecimal. So to do that, to convert to unsigned decimal to hexadecimal, you'll have to divide the decimal by 16 and get the quotient and remainder. So for example, when you're taking 422 and trying to convert into hexadecimal, you divide 422 by 16. So first divide 422 by 16, and then you'll have to keep track of the quotient and the remainder. So keep track of the quotient there, and the remainder right there. So 422 divided by 16, you'll get remainder or a quotient of 26 and a remainder of 6. So you take that again and you take the quotient and then you divide that by 16. So you divide 26 by 16 and get a quotient of 1 and remainder of 10. Then you take the quotient from that one and divide it by 16, which you'll get a 0 quotient and a remainder of 1. And then you read it from the bottom going up. So your hexadecimal number would be 1, and then 10 in hexadecimal, which is A, and then 6.
Now we're going to cover unsigned hexadecimal converted to decimal. And how hexadecimal system works is each digit corresponds to a power of 16. Starting with the least significant bit, it represents 16 to the power of 0. To the left of that is 16 to the power of 1. To the left of that is 16 to the power of 2, and so on. And in this example, we're going to be covering 1A6, starting from the least significant bit, which is 6. You multiply that by 16 to the power of 0, which is 6, onto A, which is equivalent to 10, multiplied by 16 to the power of 1, that's 160. Then finally 1 times 16 to the power of 2, which is 256. And then you add all of that up, that'll be 422.
Caution, first before we begin with this example, we have to consider the number of bits that are being converted. So if you're converting a signed decimal to hexadecimal of b bits, then the decimal should be between -2 raised to the power of b minus 1 to 2 raised to the power of b minus 1 minus 1. So for this example, we're doing signed decimal to hexadecimal. So again, we're going to take the number -422. And first you got to find the absolute value of the decimal, which is
422, and then you divide the decimal by 16 until your quotient is 0. And remember to record your remainder since it's going to be your answer. So once you have that down, you take the remainder from bottom to top, and 10 in hexadecimal is equivalent to A, right? So, and then after that you find the 2's complement of your hexadecimal number, and you get that by subtracting each bit by F, or in this case 15 in hexadecimal. So you get 9, and so F is 15, and 15 minus 1 is 14, which is equivalent to E in hexadecimal. And once you get that, you simply just add 1 to the very last bit, and you get E5, and 10 is equivalent to A, and so that's your answer.
So something important to mention is that if you're converting from signed hexadecimal to decimal, then two things are important to note. One, the number of bits matters, and two, if the leading digit is greater than or equal to 8, then the number is negative. So this is easier to see if with an example. So here are two numbers in hexadecimal, EA6 and 0 EA6. Now at first glance these might look like the same number, but one of them is 12 bits and the second one is 16 bits. And if you look at the leading digit for each one, here is E and here it's 0. So what this means is that this number, because E is greater than 8, will be negative. And this number, because 0 is less than 8, will be positive. So these are in fact different numbers. So that's what I mean when I say the number of bits matters and the leading digit matters. So now that we know how to tell if a hex number is positive or negative, we can talk about the process for converting it to decimal. If the number is positive, then we can convert it to decimal directly using the same process that we use for an unsigned hex number. However, if the number is negative, then we must first take the 2's complement of the number, then we must convert that number to decimal, and then we must append a negative sign to the final number. Now we convert a signed hexadecimal number to decimal. The example we're working with is E5A. It's a 12-bit number. Now, because the leading bit or leading digit is E, then that means that this is a negative number. So we must first compute the 2's complement. So we take F, subtract E5A from that. And that gives us 1A5. And now we have to add 1 to that. So we have 1A5 plus 0, 0, 1. That gives us 1A5. 6. Now that we've this is the 2's complement. Now that we've computed the 2's complement, we can proceed to convert this to decimal. So that becomes 1 times 16 squared plus 10 times 16, and this is 10 because A here is 10 up here, plus 6. Now these are just the digits here, times powers of 16. So this is equal to 256 plus 160 plus 6, which is equal to 422. Now, because we started with a negative number up here, then we have to add a negative sign over here to our final result. So we will end up with negative 422 as our final result. And that is how you convert a hexadecimal number to decimal.